This conference will now be recorded.
Okay. So do you have any questions on what is it?
Yes, in application layer, I had a doubt like you said in presentation layer, it is converted into ASCII, right? Like
Your
encoding will
voice is,
happen.
yeah, your voice is breaking slightly. Yeah, can you tell me?
Is in application layer, data will be in the form of. You said in presentation layer, like it is converted into ASCII, encoding will happen, right? So in application layer, data, how the data will like.
Still, I'm hearing your voice is breaking. So you're saying that from the application layer to presentation layer. See, actually, the application layer. So whatever the request we are doing. Let's say when you are typing www.google.com. So when you type www.google.com, so that request will be will be assigned, will be go to the next level layer. That's a presentation layer. So the presentation layer is responsible for whatever the request you are giving. That request will be converted into your uh, the unreadable format. Here there is actually the encoding, encryption, everything will be performed there itself. Yeah, now you can tell me what's your query.
Okay, so in application layer, there will be only the request.
Yeah, it's whatever you're requesting, right? Whatever you're if you want to access some web server, an example. So that request, the first the connection has been established there. So you're interacting with the actual web application or database server or Google server, whatever it is. Uh, that you are that's an application layer. The first layer where you are sending a request.
Okay.
Any other queries?
No.
So at the presentation layer, that encoding, everything will be performed. The encryption, everything will be performed there. And the session layer, actual session has been established with a server. And then the TCP next layer, transportation layer, will be responsible for dividing the whole the data which comes from the presentation layer. So the whole data has been break into your different segments. So each segment will be added TCP header. So the TCP header is responsible for transmission of data over the network. So which is completely, so we will discuss how the TCP works, and so we have a different along with that. So there is an alternate protocol called as a UDP. So how TCP works and how UDP works, and the difference between a TCP and UDP, and which application we will be using a TCP and which application will be using a UDP. So that we will discuss. Okay.
Okay.
So the first is a TCP protocol, which works on a transportation layer. Transportation layer. It works on transport in OSLA. It works on transportation layer. Okay. So the full form of TCP is transmission. So the name itself, it is telling transmission control protocol. So transmission, control, and protocol. So which is responsible, which is control the transmission. So how it controls the transmission? I think somebody is. Can someone please mute? Kirna, can you mute yourself? Cool. Thank you. 1 second. Okay, so if you have any issues in the voice, my voice, so just let me know so that I can correct it. Okay, the transmission control protocol, which is responsible complete transmission of data. So the data is coming from the presentation layer to transportation layer. So what it will do is it will be dividing the whole data into segments. So the TCP is responsible for transmitting of these segments over the internet. Okay. Here you are trying to do Google server or whatever, any of the server you are going. So all the segments have to travel over the network, right? So the TCP is responsible for transmitting of all your segments over the network. So along with that, so we will discuss a couple of points. So the first key functionality of TCP is it's a connection oriented. It's a connection oriented. So what do you mean by the connection oriented? So before that will be whenever the server is trying, whenever you're trying to connect the server, so you have to perform three-way handshake. Let's say here the client mission is there. That means, okay, you are client is you, and you're trying to connect one of the server. So first you have to perform TCP three-way handshake. Any of the device if you want to access the data. So first you have to perform TCP three-way handshake. Okay. The first, what is the TCP three-way handshake? The first client will be sending one synchronized packet. Okay. So the server receives that synchronization packet, then it reply back to client saying that, hey, I have received your sync packet. So that is the sync acknowledge. So the server is acknowledging to the client's synchronization packet. Along with that, it also sends its own synchronization packet. Sync acknowledge along with the server's own synchronization packet. Then the client will be reply to the server. Client will be reply to the server saying I have received your synchronization packet. So that will be the okay. So the first request will be the client. Client will send the synchronization packet to the server. The server will be reply to the client with the SYNAC along with the server synchronization packet. Okay. Then the client will reply to the server with the server's synchronization packet. It's like acknowledgement for every synchronization packet. So now the client and server both are mutually understand, and then they start establishing the so now the connection has been established between a client and server, and then it start transmitting the data. So it is start transmitting the data between a client and server. Okay, that is a TCP three-way handshake. Okay, so every time, so whenever if you want to access something, so you have to perform a TCP three-way handshake. That's a connection oriented. Even if you want to perform, so now you have completed the data transmission. Now you got all the data from the Google server. So what you gonna do? You just terminate the session. Okay, what the termination again? It is a four-way termination process. In a four-way termination process, what you are doing is, so first the client means you, and this is the server. You send a finished packet. You send a finished packet, that is a fill packet. Then the server will be responding to your finished packet, that is the acknowledgement. Okay, I have received your finished packet, I am acknowledged. Okay, got it? So now the server also send finished packet. Okay, both the second. So first the client send the finished packet, then server will be responding to the client saying that yes, I'm okay to finish. That is a acknowledge. I have received your fill packet and acknowledge to the client. Then server again send from his side is a on finish packet, and then the client will be reply to server's fill. That is an acknowledgement. It is a four-way termination process to stop the communication. To establish the communication, it's a three-way handshake. Okay. This is the process while establishing the connection between a client and server, and to terminate, it follows a four-way termination process. So that is why the TCP called as a connection oriented. So everything what happens, so you have to create a three-way handshake. You have to perform a three-way handshake, and then you have to once it is done, you have to do the four-way termination. And also every packet, another point is, when data is transferring, so client and server. So first is TCP three-way handshake. First step, TCP three-way handshake done. TCP three-way handshake done. First step. Okay. Then data started transmitting from server. Okay. From the server, data is transmitting. What happens when the data comes from the server? Okay. The client will reply every time when it receives the data. That is called as an acknowledgement. So it's sending the data and acknowledgement. Sending the data by the server, and the client will be acknowledging, hey, I have received the data. Let's say the server has the client trying to download 100 MB of data. So the server is sending as 10 segments. 10 segments means each segment will be 10 MB. So first it sends a 10 MB to server, and then client will be acknowledging. Okay, again server is sending acknowledge. The client will be acknowledged. Okay, so if there is no acknowledgement from the client, it means that the server has, if there is no acknowledgement, then the server assumes that the client has not received the data. In real time, just think like if you're talking, if I am talking, if I'm asking the question to you, then if there is no reply from you, it means that it doesn't understand by you, or you're not hearing. So that's why again, what you're going to do, you will repeat it again. Okay, you will repeat the same way here. If the client, the server is sending a data and the client is not responding, means there is some issue. So that's why the server will again resend the data. So that's how. That is why TCP called as a connection oriented. Connection oriented means every connection, every request, there has to be an acknowledgement. Okay, and the next is a three-way handshake. This is very important. TCP three-way handshake, especially when you are attending any of the interviews. So they may now ask this question: three-way handshake and the four-way termination. Okay. So the connection oriented TCP is a connection oriented. Okay. The next one is flow control. Flow control means what happens if you are sending, the client is sending a data to server. So the path it will choose is all the packets. Now these are the packets. Okay, all the packets will travel over the network. Okay, this is the internet. Will travel and then it has to reach here. Okay, so what happens once the server will, so this is the packet 1, this is the packet 2, this is the packet, okay, sorry, segment. What happened, these segments or packets received by the server, okay, what it do is, in between this packet has been dropped. Okay, this packet has been dropped in the internet somewhere, it is dropped due to some issues, due to some error. This packet has been dropped. Now the server has been received first packet, third packet, and it doesn't receive the second packet. So what the server will do is, the server will be reply to the client saying that I have not received the second packet. Okay, then client will be replying by giving the second packet. Now what happened? So you got a full data. 1, 2, 3, both the packets you got, and then your data has been, all these packets will be, all these segments will be given to the presentation layer. Then the presentation layer will perform a decoding and then give it to the application. Okay, that is the flow control. Flow control means if any of the packet is missing in the network, okay, the machine, either server or a client, will retransmit it again. They will retransmit. They will retransmit that specific packet. Okay, that is the flow control. And also there will be a windowing mechanism. So the windowing is, so how many packets we have to send. Okay, so here is the client and this is the server. How many packets each window? Let's say 100 MB of data. 100 MB of data. How many segments at a time we can send? Okay, within a time frame, within a duration, I will send 10 segments. Each segment will be a 100 MB. Let's say this is a 1000 MB file. Okay, and every time you are sending a 10 segments, and each segment will be 10 MB. 10 into 10, 100 MB you can send every time. Then the next window, you will be sending another 100 MB. Like that, and 10 times you are sending the server is sending the data to client, and then it covers the 100 MB. Okay, that is the windowing mechanism. So, and other point is all the packets so this is the internet, and this is the server, and this is the client. What happened? The data is coming, right? The data is coming, and these are the packets. What happens? All these packets are this packet 1, packet 2, packet 3, packet 4. All these packets will choose a one path when it is going to the internet. So there will be a multiple paths in the internet, right? In internet, so there will be a you know, there will be a different routers will be there to reach the destination. This is the one path to reach the client machine. Okay, we have another path as well to reach the destination. As we say, so if I want to go my hometown, so I have a multiple paths to reach the destination. So I can choose any path. Okay, so this is another path. So like that we have different paths. So now in TCP, I choose this path. I choose this path. What happened? All the packets, I have 6 packets example. All 6 packets will be routing to this specific network. Okay, that is the TCP protocol, one of the function of TCP protocol. Okay, now we'll go for a alternate protocol, and we will see the alternate protocol of TCP is UDP. UDP stands for user datagram protocol. So it is an alternate for TCP. So in transportation layer, we use either TCP or UDP. Okay, but most of the cases we are going for TCP because of TCP is more reliable and it is a connection oriented. Okay, why? What is the connection oriented? Connection oriented means every request there is a acknowledgement, and you are performing the before you are establishing the connection to the server, you are performing the handshake mechanism, and whenever you are transmitting the data, there will be an acknowledgement. There will be an acknowledgement so that it is so you will be transmitting the data properly. Let's say I'm sending hey hello how are you, I said. So between in the network, if some of the packet drop means hey hello how are you. So the packet is a how are you packet is dropping means the data is missing. And then what the transmission control protocol do? It will retransmit it saying that I have not received this packet. So the retransmission is possible. So the TCP and UDP. It's a connection oriented. TCP is a connection oriented. It is a connection less. There is no. It is not a connection oriented. It is not a connection less. It's a connection, not a connection oriented. What do you mean by the connection oriented and connections? Now, So you understand, right? Connection oriented. What do you mean by connection oriented? Every time there will be a acknowledgement, but UDP is doesn't send any acknowledgement. Okay, if you are using client and server data, this is a server and this is a client. So you're sending the data, but there is no acknowledgement in user data graph protocol. Okay, got it? That is the connection oriented and connectionless. And the second point is, okay, it is a reliable. It is a reliable and it is not reliable. What do you mean by the reliable? Any idea? So we can also say that it is a more efficient, and there is a guarantee that I can able to transfer the data. Correct. So because I am using the acknowledgement so that whenever if I miss the data, so then there is a retransmission of data is possible. So that's why it is more efficient and reliable. But UDP, when you miss the data, when there is a missing of data, so that there is no acknowledgement, so that there is no efficiency in terms of data. Let's say if you send hi, how are you? You're missing how are you means what is that? So the half data is in the actual data, what you're trying to ask, that was missing. So that is the UDP. And here, as I said, the TCP choosing one path to all packets choosing a one path to reach the destination, right? One path to reach the destination. But in UDP, this first packet will choose this network. The second packet will choose this network. The third packet will choose another network. Okay. See here, every packet is independent. Every packet is independent. So it is going one route. This is going one route. The destination is same. This is only destination. The server is the destination, but we have a multiple path. We have a multiple paths, and then at the receiver end, all these packets will be received from different paths. We have in a network, we have different paths. So every packet will routed to different routes, and then finally reaching to the destination. This is an example. You're transmitting your luggage from your hometown to your hometown, your Bangalore to your hometown. So couple of things, couple of your home things like a fridge, air conditioner, all electronic goods you transported from one route. Okay, and other things, so for other things, your chats, everything you transported from another route. You are using another transportation mechanism, like any other transportation vehicle, and you are sending another route. Okay, at the end, finally you will be reaching to your hometown, and your home only. But choosing a different paths, different routes, and finally reaching to the destination. That's a UDP. And the TCP is you're using the 4 vehicles for transporting your home, fridge, everything, and all 4 vehicles will go same route. But UDP is using a different routes. By what was in terms of let's say now one of the road, whatever you're transporting all your things, all your luggage by 4 vehicles. and you're using a one path. What happens if that road blocks? Okay, if that road blocks, or if something the road damage is happened between, and you're not able to go that route, what happens? What happens if the complete road is blocked and your four vehicles went single route? So did all your luggage will go to your home?
No, it will get returned.
It will be
Get returned. Returned.
It will be get returns because your all your four vehicles went in a single route. But if you use UDP case, so one road is blocked, you send your all your luggages, four vehicles in four different vehicles, four different paths. So now the one road is blocked, but all other three are good. So you will be receiving all other three vehicles to your destination, your home you will be getting. So that is the one advantage in terms of in UDP. Okay, so that's the reason UDP will be using for such applications like video conference. So video conference and all will be used. UDP protocol is the best suitable protocol because if something wrong. So because when you're talking, when some video conference with a client, something you're talking, okay, you're talking something means that data you're talking, whatever the video conference you're talking and your video presentation, everything will be converted into your packets, and each and every packet will be routed into a different paths. So when one of the, let's say five, your complete video is a five packets example. One path is having a high traffic. So what happens? The packet will gets dropped, but another four will be reaching to the destination. Means, so there was a slight disturbance in your video conference. Your video made little blurred because of one specific packet is missing. Okay, because all other four packets are reaching, so that the video will be visible with a little bit disturbances. But if you choose example, if you choose a TCP protocol in a video conference, what happens? If you choose TCP in a video conference and your video conference with the client or any of the customer, okay, then there is a disturbance in the path. Then there is a disturbance in the path. Okay, you are performing here to here. So your client and you. So you are performing a video conference. The complete video conference gets disturbed. Got it? If you use the UDP, all the packets will be routed to different paths. If something one packet down also, all other four packets successfully reach. Okay, then there is no disturbances with your video part. Okay, that is the one of the difference between TCP and UDP. Got it? So we and TCP is slower. TCP is slower and UDP is faster. Why TCP is slower? Because whenever it sends a data, it should expect a acknowledgement from the either client machine or server. So let's say the server, this is the server. Server sends us some data and it waits for the acknowledgement. Okay, sends a data, acknowledgement. Sends a data, acknowledgement. So that is the reason every time you are expecting an acknowledgement. Okay, so that's the reason TCP is slower, but UDP is faster. Why? Because there is no acknowledgement procedure. There is no acknowledgement procedure. Okay, and because of this acknowledgement process, this is more. There is a guarantee that the guarantee of data delivery, right? Whenever guarantee of delivery means the packet gets dropped here, then the server will be wait for some time. Okay, and then yes, oh yeah, I have not received the data. Can you resend back? Can you resend to me? Okay, can you resend me? So that if the data is failed to receive failed to receive, so then the receiver will reply back to the actual mission saying that hey, I have not received this data. If there is no acknowledgement, the client sends a packet or server sends a packet to the client, and there is no acknowledgement, so it will retransmit the data, so that there is no missing of data. That is the reason it is a guarantee of delivery, and there is no here the packets are individual. Here the packets are gets individual in a UDP. Okay, all the packets. This is the packet 1, packet 2, and you are sending. Okay, this is going one route and this is going another route. If this fails, there is no acknowledgement. If this packet gets failed, and there is no acknowledgement process in the UDP, so that there is no chances that retransmission is there is no retransmission because there is no acknowledgement. So only packet second packet will receive. That's all. The packet 1 will be dropped means dropped. There is no again a transmission. Okay, that is another difference. So how many differences we know? So first one is, what is the first one?
Connection oriented.
Yeah. So connection oriented. First is the connection oriented. It is a there is no. It's a connection less. Means there is no means sending acknowledgement, but here is a proper acknowledgement should be there. Acknowledgement should be there. Here there is no acknowledgement, and it is a
Reliable. Slow.
yeah, it's a slower because of it's sending every time acknowledgement when it receives the data. It is a faster because there is no acknowledgement process, and every packet is routed individually and reaching to the network. So here retransmission is there. If the destination has not received the packet, here there is no retransmission of data. Okay, it is a more efficiency because guarantee of delivery, but this is not a efficiency because no guarantee. No guarantee of delivery. Got it? So specifically, it uses applications like HTTP, FTP, SMTP. All these uses a TCP, TCP, TCP mechanism. So when file transfer protocol or SMTP, a lot of us there, a lot of POP3, all these uses transmission control protocol. UDP especially used in video conference applications. Video conference applications. Why? Because it's, as I said, there is no, if something goes wrong also, one packet gets down, one packet not transmitted, or one packet gets dropped, so other packets will receive. So that it's a real time. Video conference is a real time, right? Video conference is a real time. If the one packet drops also, other 100 packets will send. One packet gets dropped, other 100 packets successfully reached by different paths. So your video or live conference will not disturb. If you use a TCP, what happens? So you're using a one path. You're using a one path, and you're all, if in that path there is some network congestion or a network is not good. So what happens? All packets will disturb, and your complete video will be stopped. Got it? Any questions there? Difference between TCP and UDP.
In three-way handshake, first you transmit a packet from client to server, right? So first client will be asking for a connection like synchronization.
Yeah.
And then like in second step, server will
Handshake,
be
there is
acknowledged.
a
Sorry, what can one speak? Can one person speak? Yeah, Deepna, what's your question?
No, in three-way handshake, first will be synchronizing between a client and the server asking for a connection. And in
Correct.
second step, like server will be responding and telling that, okay, I'll provide a connection and acknowledgement will be there. And in third step, what exactly will happen between a client and the server? Either server will respond again or else client.
Server sends its own synchronization packet. See,
Okay.
how the packet looks like is, the first is client will send. Okay, they have a different flags in a header. Okay, TCP header. We have a different flags. One is synchronization flag, SYNAC. Okay, and this is a SYNAC. This is a and this is a synchronization. SYNAC, add, and we have a other flags. Finish. Okay, RST. We have a CWR control code issue. So like that, we have a different flags in the TCP header. So when you send synchronization packet, the first when a client sends a synchronization packet, it should be set to 1. The synchronization packet should be set to 1, and all other packets will be 0. So this request will go. Okay. Now the server will reply to the client. Then that cases, what it replies, the replies looks like this. Okay. syn, again synac, and this is the act, fin, reset, and CW. Okay, we have another one or two flags also there. Now this is set to be 0. Synchronization flag, this flag is set to be, sorry, this is set to be 1. Okay, got it? This is set to be synac, and this one is server's own synchronization. Got it? 2 flags is set here, and remaining all 0. Got it? The first is, this is the client, right? Client side. This is the synchronization. First sending the synchronization packet means this flag is set to be a 1. So this is how the packet looks. This is how the TCP header looks. Okay, this flag is set to be a 1, and remaining all flags will be 0. When server, this is the server reply. This one is the server reply. Okay, that cases synchronization. This synac is the acknowledgement to the client synchronization packet. Along with that, server's own synchronization, and remaining all fields set to be 0. Then now this is server synchronization packet, right? The client has to reply to this in the third flag. This is the first packet, second packet. This is the first packet from client to server. The second packet from server to client. So here only synchronization packet. Here is synac, and along with the server's own synchronization. The third packet looks like that is the client to server. Okay. Now how the packet looks? Synac, act fields set to be 1. Got it? I'm sorry, just confusion here. We have to remove the synac. It's an acknowledgement. Only acknowledgement. There is no synac. So synac. Got it? So first is the sync packet is set to be a 1. The second phase, acknowledgement along with the server's own synchronization packet. Third one is again acknowledgement for the client's server's own synchronization packet. Confusion still?
No.
So every time when you are sending the data, while establishing the connection, sync flag first packet is a sync packet. It will be set as a 1 and then sent to the server. From the server response, the 2 flags will be set here. The one is acknowledgement field, and another field is it's a server's own synchronization packet. So the 2 fields has been set here. Okay. The third one is client to server. So here is it's like a mutual understanding of between a client and server. So what exactly why we go for a TCP three-way handshake? So in a TCP three-way handshake, they will share a couple of information. The client and server has to be synchronized. They have to synchronize. Means what kind of how many packets per window, how many packets you want me to send. Okay, and so whether the retransmission, so within a certain how much time I have to wait for a retransmission. Let's say I send one packet to you. So how much time I have to wait for an acknowledgement. So that information both the client and server will exchange during this three-way handshake. They will be like a mutual agree between yes, I want this much time. I'll wait for it this much time. If there is no data, I will after this much of time I will retransmit the data. So that synchronization. So they have to synchronize the client and server has. They will synchronize for this kind of data. It's a kind of agreement between the client and server. Then after the agreement, they started transmitting the data. Got it? We'll see there will be a so we have see TCP. This is the TCP header loops. Okay, transmission control protocol, and this is the how the header looks. Okay, and so we know all these things. So transportation layer and designed to send the data packets over the network, establish a reliable end-to-end connection before sending any data. See here, so we will be seeing a different packets. See, I said by mistake is a SYNAC. There is no SYNAC. SYN, ACK, and so these are the two flags we will be using while establishing the transmission. First, in order to establish the connection, we are using the SYN, and ACK. So when you are sending the data, sync flag will be set 0, and all other these flags will become 0, and this one is a 1. So that, and then this packet will be sent to server. That means the server will see that packet and understand that this is the synchronization packet coming from the client. Then the server will be responded with this synchronization packet. First is acknowledgement packet it will send, and along with the synchronization packet. So these two fields will be set to 1. Okay, that means this is acknowledgement for client packet, and this is its server's own synchronization packet. Then the client will be replied to only acknowledgement field. Only acknowledgement field. Only this flag is set to be 1, and all other flags will be 0. Okay, this is how TCP three-way handshake works. I'll try to show tomorrow in a wire shop. If possible, I'll try to show that how when you are trying to access a google.com, so what happens? We'll capture the packet, real-time packet, and we'll see the complete packet and what are the fields are set, what are the different flags we will see them. Yeah, I'll try to show it tomorrow. And we have this is the header. See, header is a direction. The meaning of a TCP header is it's a giving a direction how to reach it's like a head of the data. So data is like the body. Data will be the body of our just imagine like a human body. So the data is the whole body, and the TCP header is the head, which gives a direction how to go in the internet. Okay, so the TCP header having the source port, destination port. Source port means the computer's own whatever you are sending, which port you are sending, and which port you are gonna access. Let's say I want to access some Google server, then it automatically the destination port will be 80 because that is the HTTP traffic. If you are accessing HTTPS, then that will be 443. So the destination port here, the source port will be a random. It will be generated by the computer. But when you are accessing some website, then automatically it will be. Let's say you are accessing HTTP, you are accessing some banking site. then automatically the destination port becomes a 444. That automatically the internet will choose that port. Okay, sequence number, acknowledgement number. So we will discuss later because this is a more complicated topic. Sequence number will be when you're sending a data automatically. When you're sending a packet, every packet have a random sequence number created in internet. When you send a packet, automatically there will be a sequence number will be created for every packet. Every packet there will be a unique sequence number, even acknowledgement number also. Okay, this is specially, and these flags are specially used for establishing the connection and termination. So now fill packet, this fill packet will be used during the termination process. As I said, four-way termination. What happened? The client will send finish. Means this packet is said to be a 1 and all other packets become 0. Means this says that the client says that stop sending the data. Okay, and then this is the synchronization. So again the server replies saying that yes, I'm acknowledging, I'm ready to close the session. Then server also send its own pin packet again, and the server will be client will be sent to acknowledgement from feedback. This is how the four-way termination process works. We will discuss this IP header later. So UDP protocol. Why we were going for UDP is an alternate for TCP, and using services like computer gaming, voice, video communications, live conferences, and all. We will be going for UDP and the UDP header. So the UDP header will be the source port LAN. We only need source port, destination port. So which is this header, because here there is no any connection oriented. So that's why there is no any flags. You are seeing any flags here? No, because there is no any connection oriented TCP three-way handshake or four-way termination. Nothing is here. That's why there is no any. There is no any flags. And so applications where the UDP uses. So these are the different protocols they use. NTP and DNS, all these things. We'll discuss the NTP, what is NTP, what is the DNS, DHCP, and all these things. These are the routing protocols which are used in the networking. So we don't need to learn about these things because it doesn't help you for us. These are purely routing protocols, how to route the traffic. These are the routing algorithms, different how to route the traffic. But we don't, as a security analyst, we don't need. This will be helpful for the network engineers. So when they are routing, there is any issues, how to troubleshoot all these things. So this protocol will be helpful. And traceroute, record stamp time. So we'll discuss the traceroute part as well. So any questions in the UDP section, TCP section, TCP part, UDP part?
Yeah, you said that if you send the packets to the server and it will respond that packet, if any packet is missing, it will respond that is in this packet is missing, right? How server will knows that this packet is missing?
See that they have initially when establishing the connection itself, there will be this many packets will be routed to. There will be an agreement, connection agreement between a client and server. So there will be a let's say every packet have let's say 100 packets you have received. Okay, each packet have labeled as the packet number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you have received the 10 packets. Got it? In the 10th packet, one first packet received, second packet received, third and fourth number not received. Okay, 6, 5, 6, 7, 8, 9, 10. There is a 4, 5 or 3, 4 is missing. Okay, these numbers are missing. So automatically what happens? The server will send, will ask the client, or client will ask the server saying that, hey server, I have received the first packet, second packet, third packet, but I have not received the fourth and fifth packets, and I have received the sixth packet, seventh packet, eighth packet, ninth packet, 10th packet. So then it will be, the client will be, or server will be, the server will be reply back retransmission.
That's why the okay. That's why how the server will know that this much packets are there and
Gautam, your voice is not audible.
both are missing. How the server will be knowing?
Gautam, can you tell me that I didn't, your voice is keep on breaking. Can you tell me once again? Gautam. Gautam. Hello.
That's yeah. How server will be knowing that this packet is missing? Is there any fixed packets for any transmission?
No. Let's say server sends the data to the
Every
client, right? Wait for every packet. Whenever it sends a packet, first it sends a one packet.
Okay.
There is no reply. There is no reply from other end. There is no reply from other end. So when I'm, let's say I'm sending a 10 packets or 10, 10 I send you 10 pages, 10 letters via postal. Okay, 10 letters. Okay, if I got an acknowledgement from the other end saying that I have received the 8 postals. Okay, and two missing, right? So there is no acknowledgement for these missing 2. So that again I will retransmit this packet. Got it? Once show you. Let's say this is the server and this is the client. Then the server sends first packet. It sends the second packet. Got the acknowledgement. Third packet. Acknowledgement. But fourth packet, it sends the fourth packet. Okay, but there is no acknowledgement. The server doesn't receive the acknowledgement. It sends a fifth packet, doesn't receive the acknowledgement. So there is no acknowledgement from the server. Sorry, client machine. That means the server assumes that there is no acknowledgement from the client. Okay, this data has been missing. It will retransmit the data. This is what your question? How the server come to know when some missing packets? That's what your question, Gautam?
Yeah. That's my question.
Retransmission, when something is missing from the when after it sends the data, but there is no acknowledgement, means it wait for, that is what in the synchronization time, the connection establishing time itself, there will be a mutual agree between the client and server. Okay, 1 minute of time if there is no acknowledgement, or 2 minutes of time there is no acknowledgement from the other end, so it will retransmit the data. So that's why TCP is the guarantee delivery of data. Any questions, Kirtana? Any questions you want?
Four-way handshake, like client will terminate first or else a server?
No, client will not, server will not send, because you are accessing the data, right? So you're accessing the data means you are requested, you're downloading the data, right? Your access. So yeah, if you want, let's say you're downloading some PDF file, okay? You completed your downloading. After that only you can close a browser, so that your, or you stop the, let's say in between you're downloading a 10 MB file. So in between you stop, you pass the data, or you stop means, so then you stopping the data, you stopping the connection. So it's a purely from the client side. There is no termination from the server side until unless server having any issues. If the server having some issues, there was a connection failure issue from the server side. Those cases, you will be getting a reply saying that you will some 404 error or something. You will get it, the connection failure. Other than all the cases, you will stop the connection.
Okay.
So the next section will be IP address and the MAC address. We will discuss. So IP address is a simple so to identification of any of the device. Let's say I'm connected to the internet, right? So I'm connected to the internet means, so automatically my system will be assigned the one IP address. So because to identify any of the device in the internet, so you must need a one IP address. It's an internet protocol. So in order to identify any of the device in the network, so you must need a IP address. Let's say you are working, your identification is your name. So any people can communicate you, or anyone can communicate you with your name. If you don't have a name, there is no identity. So the same way, in order to any of the computer want to communicate other computers, they should have some identity, that is the IP address. Okay. Let's say I am sending some data from my mission to other mission. The other mission should have an IP address. So then only I can able to communicate. Let's say I wanted to send some data. So what I'm going to do, I just give an IP address to that, and I send to that specific device. Okay, it's a IP address is a, it's a logical address, and it identifies where exactly the machine is located in a network. MAC address is a physical address of the device. Let's say one example. I have sent a postal address like some envelope or something, some postal code. I am sending us some information with a postal code. That is some post address. Post address in the sense some document is there, some few documents is there. I am sending to you, and you are there you're working in some company. Let's say you're working in IBM. Okay, IBM is your company, and your name will be something XYZ. So now I will write you're working in IBM and your name. So then what happens? That specific courier will be sent via post, and then first where it will reach. It will reach to my company. And so my company reception guy will take that and he will read who is this guy. This guy is the name and which specific department, everything they are mentioned. So that my receptionist guy will deliver that courier to me. So here the IP address is my company name. So my identity here is my company name. Where exactly, which department, my name, everything is a MAC address. So MAC address is the physical address of the device. So the IP address will be helpful to identify where exactly my computer is located in the network. So identify the network. Identify only the network. So in the network, where exactly located? What is my physical address will be decided by that. Will be the MAC address. The MAC address is the physical address, and it is a unique address for every computer. Got it? Let's say there are n number of computers are there. Okay. So this is the ABC company, and this is the XYZ company. So now I am sending a data. This is the switch, router, and everything. Then I route it to internet via internet. It will go to this specific system. So here you're sending the data, the address you're sending. This is the source IP address, your IP address. IP address is something 10.10.10.0.0.0.1. This is your mission IP address. The destination where you want to send 100.10.0.1. This is the destination. You have to route here. This is the 100.10.1. It will go here. So the only IP address will be helpful to reach the destination network. Okay. So what happened? The physical address of the mission can be identified based on the MAC address. So here only to deliver which network it has to go. It's an identification of device where exactly in the network. So here this is a network. In this network, so any of the mission have this IP. Any of the mission have this IP address. Okay, but the MAC address will be unique. The MAC address will be unique for all the missions. So what happened here? The switch will be there. The switch will identify which mission, which IP address 100.0.1, which mission belongs to 100.0.0.1. So that identifies the MAC address helpful during this or finding this specific mission. So IP address is to identify where exactly the mission in the network. MAC will be helpful to identify the physical location of the device, where exactly, what exactly the mission is. Okay, that's the difference. Any questions? Still doubt? Confusions? So IP address is a logical address. We'll discuss more different. We have different types of IP addresses, classes we have. So we'll discuss this, but it's just introduction of IP address. So IP address is to locate. So even the two different computers want to communicate means they should have the IP
address.
Okay, to locate where exactly the mission is, the IP address will be helpful. The MAC address will be to identify the physical location. Okay, if you are using two different networks, okay, to identify the mission, the MAC address will be used. So MAC address is unique. My mission have a one MAC address, okay, and your mission have a one MAC address. And even MAC address is unique. It doesn't change once you purchase laptop. Your MAC address is a unique, but IP address when you connect now, your IP address is one. So now this is my IP address. Okay, but MAC address, and after some time I disconnect the internet and I connect back, so my IP address will change. My IP address will change. So this is assigned by my internet service provider. When I'm trying to connect my ISP server, ISP provider will assign this IP address to me. So ISP server having the DHCP server will assign them on IP. But the main MAC address will be same. So why IP address is required? To communicate with the other systems. We'll discuss more about more in detail tomorrow. The MAC address, IP address. So how specifically when you receive the packet from the source with an IP address, how it identifies exactly the mission. Okay. The same way I told you, the courier, when I receive the courier, my first identity is my company name, then my department, my name, everything. So when the courier boy sends, when you send, the receptionist will take my courier, and after that, so he will differentiate who is that, and exactly he will deliver to me. The same way here. So first idea is my network. So the first source, the postal guys will identify only the network. So once the network you identify, so that's a. So he identified my network. My network is my IBM from my company IBM. So he identified. So the reception guy knows. So in IBM where I am sitting, right? This is about the same thing. IP address also same. First the system identify the network. After identifying the network, then it identifies the mission. We'll discuss with the one real world scenario how IP MAC works. So for that, to identify the MAC mission, again address resolution protocol will be there. So that gives the IP address to MAC address. Okay, that we'll discuss. How does it? It's again it's a 10-30 minutes concept. We'll discuss tomorrow. You can if you want. If you have any queries, you can go through the recording. That help you for definitely, and even I'll send you by evening the third class. Okay. Okay. Then anything else you can ask? Best please share your series so that we will try to change it as per the security. Sorry, you guys have Gautam and Krishna, you guys have already prepared the CV?
Yes.
Yeah, I have old CV. I'll share
No,
it.
security in terms of security role.
Yeah.
Security.
Yeah, I have that.
Okay. Fine. What about Naukri? You uploaded Naukri.
Yes, we have
Yeah.
already updated in Naukri all those monster, all those things. But the thing is, experience is the problem over there.
So
We
how
don't
many?
know whether we kept it correctly or is it valuable or not. We don't know actually.
Do one thing, just share me your Naukri profile, credentials.
Okay.
So we will try to share the key skills. The key skills are the important things. So based on that, only the recruiters will be reach out to you guys, and your CV also. If the CV, we have a good CVs. If your CV is good, then yeah, we won't do anything. I won't do anything. If the CVs are not up to the mark, so that I'll try to change it. And yeah, and make sure that you guys have to upload your now update the CV every day, at least 7 o'clock or 8 o'clock, and that changes will be repeated. That changes will duplicate in the Naukri database after 2 hours. Let's say if you upload, you do some these changes, so that changes will be replicated after 2 hours. If you upload your CV, that uploaded CV takes some more time to replicate there. And whenever the recruiter is trying to search, so they will always, the Naukri database will always show whoever is done the recent changes. Okay, then only those profiles only will be up in the profile. Whenever recruiter is trying to search for security guys, so whoever done the changes recently, their profile will be up. Their profile will be showed in the first place, so that they will call those people. So my suggestion would be doing everyday update before 2 hours, like 10 o'clock means you should done it 7:30, 8 o'clock, so that your profile will be up in the database. Got it?
Okay.
Send me your credentials, and Rajiv, you can share me your CV, basic CV, and we'll do the changes. We'll put it in an order. So as I am expecting that, I'm expecting after the lockdown, so will be expecting the more calls. Yeah, definitely in security. I think right now itself we have calls not up to the mark, and after we have two guys, both the guys have done all the things. They are at to release offer letter because of this. So they are not released. Maybe they told every month they will be released. We'll see. And I'm expecting more opportunities with me. Okay, fine. Anyway, you can ask me in offline if you have any questions.
Okay.
Okay. We got you.
Okay.